is a little bit shorter as far as the exercises goes from yesterday. So we have a little bit of time to go back and review everything we've done so far. So that's what I'm going to start the class with. Make sure you know your laws of exponents. If you don't, you're going to be sunk for the rest of the year. Then we'll go over scientific notation and multiplying polynomials. And then the new material is factoring out greatest common factor and factoring by grouping. And our test is next Thursday during class time. So what I'd like to start out with, and then I'm going to let y'all spend a few minutes doing some of these, and then I'm going to call on y'all. And if, as a matter of fact, I'll probably tell you the problem I'll call on you for before I do that. So for example, here, these are the scientific notation problems I want y'all to do. And these are also on Blackboard. If you want to pull them up, you can. So I want you to do those 4 scientific notation problems. And then Chris, I'm going to call on you for the first one, and Aurora, you for the second one, and Timothy, you for the third one, and Hunter, you for the fourth one.
Do we have this paper, or is this just you guys?
It is on Blackboard, but yeah, it's also on Blackboard under the notes tab.
Lecture notes?
Yes.
Which one is this? 5.1?
5. It's under the one that's 5. Let's see. It's under 6.1. It's under
6.1. Okay.
Yeah.
Because I saw at the beginning it says that we were going to be reviewing 5.1 or something like that.
Yeah. So but I put it under the 6.1 notes.
Oh.
Okay, let's go ahead and talk about these. So Chris, did you do number 1?
No, not yet. I'm still trying to figure it out.
Okay. So let's talk about it then. So, scientific notation has to have how many numbers in front of the decimal? How many integers in front of the decimal? Exactly how many? You remember?
Like around 3 or 4.
No. Okay, so to be in scientific notation, remember that you have to have exactly 1 integer in front of the decimal. So in this case, we have 0.00365. So to get this into scientific notation, we have to move the decimal point 1, 2, 3 places to the right. So that would be 3.65. And then to make it equivalent or equal to the original number, we would multiply it by 10 to what power?
Three.
Yes, 10 to the third. Okay, we're going from a very small number to a larger number. So that means that we have to multiply by a power that's a positive power on the 10. Right. Okay, so number 2, Aurora, did you do that one?
I wrote it as 8103 with 6 zeros.
Yep.
In the decimal.
Perfect. So here it's times 10 to the 9th. That means you're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right. And so the number in standard form would be 8,103,000,000. Okay. Timothy, did you number 3?
I did. So I wrote it as 7.9901 times 10 to the 9th.
Times 10 to the perfect. 10 to the 9th. Yeah. So we went from a really big number to the 7.9901 number. So that means we have to have a positive exponent on our 10. And finally, Hunter, what about number 4? I know this one didn't come out, you can round it where you feel comfortable rounding it.
Well, I did not round it, but I got 4.23805263 times 10 to the 22nd. I'm not sure if that's right though.
22nd, let's check it. Okay, so tell me what you did first. What's the first thing?
I broke it down into 40.2615 divided by 950.
Okay, and that gave you
10 to the 15th divided by 10 to the negative 5th, or times 10 to the 15th divided by 10 to the negative 5th.
Okay, so you got, hold on just a second. My calculator just died. 40.2615 divided by 950. And that gave you, tell me what that gave you again. It gave you point
0.0423805263 times 10 to the 20th.
Times 10 to the 20th. And he got 10 to the 20th because he subtracted those exponents, and 15 minus -5 is 20. Okay, and then what did you do?
And then I moved the decimal points 2 places to the right to make it scientific notation and just up the exponent.
Okay, so we went from small to big, right? To bigger.
Right.
So what do we have to do with the exponent?
Reduce it.
Yes, right.
Okay.
Right.
I figured I got that step backwards.
Yeah, you just have, I know I always have to really think about it too. If you're going from if you're going from a smaller to a bigger, then you reduce the exponent. And if you're going from bigger to smaller, you increase the exponent. Good. Okay. All right. Any questions on those, guys? Are those making sense? Okay. So now let's go to rules of exponents. What do you have in here? Okay, so Elliot, would you do number 5? Letitia, number 6. August, number 7. Olivia, number 8. And Gabriella, number 9 and 10.
I can't see number 8.
Oh, I'm sorry.
You're okay.
Yeah, I guess, oh, thank you. Elliot, did you get number 5?
I'm not sure if this is it, but is it like negative 1/25th?
Yeah,
The wait, that was it?
that's it, right? Yeah.
Okay,
Stop.
cool.
So what's 5 to the 0?
5 to 0 is basically 1.
This one, right? So basically, all you have now is -5 to the -2nd, right? Because anytime you divide by 1, you're just left with whatever's in the numerator. So then what did you do from there?
Oh, then from there, I noticed that there was a -2, so it would obviously be a fraction. There would be a 1 at the top, and then um 5 times 5 would be 25, and since that negative is in front, it would be negative.
That's right. The square does not go. That's really, I'm really happy with that, Elliot, because that's every single one of these kind of has something about them that someone would miss. And so a lot of people would write that as 1/25 because they'd want to square that -5 as well. But the negative is not included with the exponent because there's no parentheses. So you did that exactly right. Awesome. Okay, Leticia, what about number 6?
I'm still working on that.
Okay. You want me to come back to you in a minute?
Yes, ma'am.
Okay, I will. And then if you're still struggling, we'll go through it together, okay? Like I
Okay.
said, each one of these has something about it that might cause people to be confused. All right, what about number 7, August?
So I know you have to flip it to make it a positive,
Okay,
but I kind of don't know what to do after that.
okay, so you have to do what would that 5 just, what do you think you do with that 5?
I really have no idea.
Okay, so give me a guess. What would you think? Like if you had something like this, 2 to the 5th, what would you do with the 5? What does that 5 tell you to do?
Does it time, I don't know, times it
So you take 2 and do what to it? Multiply it
5 times.
5 times, right? So if you didn't know anything else to do with this, what could you do with the 2b over a? What could you do with that if you knew nothing else but what a 5th power does?
Multiply 5 times.
Exactly. So even if you forgot what to do, if you know what the power of 5 means, you know that this is what it means, right?
Yeah.
Okay. So then if you multiply 2 times 2 times 2 times 2 times 2, what would you get?
32b.
B to the
5th.
Yep. And what would the bottom be?
A to the 5th.
Now there is you really don't want to do that every single time if you don't have to, but you can always do it. If you do forget, you can do it. But the rule of exponents helps so much more because it prevents you from having to do all that writing out. There's a lot of exponents that says the power rule says that if you've got a 5 on the outside of a parentheses, you just apply it to everything on the inside. So you would take 2 to the 5th, which is 32, b to the 5th over a to the 5th. But if you forget, then just say, what do I know I have to do? And then do it the long way. That'll work too. Okay, Leticia, what do you think?
I'm still working.
Okay, tell me okay, so what do you think, what we did on number 7, what does this power of 3 tell us to do with what's on in the inside of those parentheses?
It needs to be multiplied into the inside.
Okay. Okay, so what is -3 to the 3rd and x to the -2nd to the 3rd? So what is -3 to the 3rd? It's just -3 times -3 times -3, right?
Yes, ma'am.
Okay, and that's just going to be negative.
No. Oh, 27.
And then what's x to the -2nd to the 3rd? What do you do with those exponents?
I forgot.
You multiply. The power rule says that if you've got an exponent on top as a power of on top of another power, you just multiply those. So that's going to give us 27x -6, right? But then we can't leave it like that. Leticia, why can we not leave it like that?
Because of the exponent. It
Right.
needs to be a positive.
Yeah, so how do I make that an x to the -6 turn into a positive exponent?
Can you divide it?
Okay, so you're gonna, I think I understand. You're gonna change it to a fraction, right? So the
Yes.
-7 is gonna stay on the top, and the x to the 6 is gonna come down and become division. Right. All right, so number 8, Olivia.
I got -15. over x to the 7th.
Yep, beautiful. Okay, so tell me how you did that.
Well, I multiplied 5x and negative 3x.
So
And
five-
then
Okay, so 5 times negative 3 is negative 15, and then
I did the exponents as well. And then turned it into the fraction so
right.
that the negative exponent would go away.
Great, great, great. So she just multiplied the 5 and the negative 3, got negative 15. Then she multiplied the x to the negative 2nd, x to the negative 5th, and got x to the negative 7th because you add the exponents. And then to get rid of that negative power, she flipped it down into the bottom. Okay, so Gabriella, I gave you 9 and 10 because they're very closely related. What'd you get for number 9?
For number 9, I got negative 11.
Yes, so negative 11 times 1 is negative 11. Great. And what about number 10?
I got 1.
Is 1, right? So no matter what you have to the 0 power, it's always going to be 1. And the reason that this is negative 11 is because the 0 power only applies to that x. So you get negative 11 times 1. Great. Thank y'all. Okay, so if you're struggling with those, go back and do some more. I have put a review at the end of the review for this is already there. So there are several problems that you can practice on that. Again, the rules of exponents are so important. All right, operations with polynomials. Okay, so go back through here. Michael, would you do number 11?
Okay, so we do 15 x, and then we add the 2's, the second powers of the x's, so that's 15x4. And then what I do when I'm doing this is I just start with the one that's to the most left, and then I just start multiplying it throughout the second one. So
Awesome.
if we do that, and then the second one would be 3x to the other x would have like a 1 over it. Like imagine it's to the power of 1. So then we add that to the 2, and it's 3x to the third power. And then the minus 4, we do minus, oh, wait a minute. No, 3 times 4 is negative 12. And then that's x squared. So that's what
Okay.
we start with.
Okay.
And then we just keep going where the second one, now it's negative 2x multiplied by positive 5x squared. So that was going to be negative 10x to the third. And then from there we go to, it's going to be negative 2x squared, second one. And then we go from there to positive 8x. So that's how we start with that.
Yep.
Right. So then, and then we just simplify it from there.
Okay.
15x to the fourth is the only one that's like that. So we're just going to leave 15x to the fourth alone. And then we're going to go the cubed ones. There's 2 cubed ones, plus 3x, and then minus 10x. So that is going to be negative 7x to the third. And then we go to the squared. So there's 2 of those. So that's negative 12 and negative 2. So that's negative 14x squared. And then the final one is going to be 8x, but there's nothing else to do. So it has to just leave that alone. So that's 8x. I don't think it can be simplified any more than that.
Nope. Great. Okay. So I know you can use the box method if you want to do that. If anyone wants to see it using the box method, I would be happy to do that. I like the way that Michael did this. He just used the distributive property. And when I do the distributive property with problems like this, I start grouping as I go. So like when I started with the second term of the first polynomial and multiplied it by the 5x squared and got the 10x, negative 10x to the third, I went ahead and put it right under the 3x to the third so that I could see that they go together when I'm adding the like terms. Would anyone like to see that using the box method? Or is everyone pretty
Well,
happy?
yeah, I guess. I don't see why not.
Okay, well, let's do box That's not good then.
Hmm.
Okay, so we've got 3x squared minus 2x. And then on the top, we've got 5x squared plus x minus 4. So, okay, so now we take 3x squared by 5x squared, and that gives us our 15x to the 4th. And then 3x squared times positive x gives us 3x to the 3rd. And then 3x squared times negative 4 gives us negative 12x squared. And then we come back through with the negative 2x. Negative 2x times 5x squared is negative 10x to the 3rd. And negative 2x times x is negative 2x squared. And negative 2x times negative 4 is positive 8x. And then we're just looking now at this piece right here. And so we have the 15x to the 4th. And these two can combine right here. So that would be plus minus 7x to the 3rd. Then these two can combine right here. And that would be minus 14x squared. So really it is just the distributive property. It's just a way to organize things if you like to do it that way. All right. Number 12. Aurora, would you do that one? You tell me how you do it.
So I'm gonna go ahead and distribute the negative first and make it negative 5x squared minus x plus 4.
Great.
Then just combine the like terms. Negative 2x squared wait. Minus 2x.
Okay, negative 2x minus 1x, right? Because this is like a 1 here.
So minus x.
Okay, so what is negative 2?
Oh, minus 3x.
Yes, thanks.
Plus 4.
Plus 4, right. Right. And my cautionary tale here is that when people see these parentheses, for some reason they want to multiply. They just automatically go, oh, that's a multiplication problem. But if there is a plus or a minus sign between the parentheses, then it's not a multiplication problem. It's an addition or subtraction problem. Okay. And the thing you have to really be careful of is distributing that negative. Okay. Timothy, how about number 3?
Okay. All right, so distribute over 5. Real quick, I'm sorry. Did you say number 3 or?
Sorry, I might have said 3, but I meant number 13. Sorry.
13, right?
Yes, sir. Yes.
Okay, all right, good. Sorry, I was getting confused. Okay, so yeah, you're gonna do 5x times 5x plus 1 on one side. Distribute, of course.
5x times 5x. Okay, so what's that going to give us?
25x
X what?
to the square
Okay,
plus 5x.
plus 5x.
And now we're gonna distribute the 1 onto the other side.
Okay.
So it should be negative 5x.
Okay.
And then -1 times -1 is -1.
Okay,
And then since these are both the same variable, they cancel each other out. You come up to 0.
okay.
There should be 25x squared minus 1.
So your final answer is 25x squared minus 1. Great.
Okay. Sorry about the mix up. We just
No, I probably
my laptop's having all kinds of problems today.
me. I probably said number 3. So Hunter, how about number 14?
What are those called again?
That is
Or-
called the sum and difference of squares, and that's a factoring a rule that we'll talk about that I think day after
Okay.
tomorrow.
Because there was a term for those and I can't remember what it was.
Well, they're each other's conjugates.
Conjugates maybe.
It's conjugates on one side, it's a difference of squares on the other. But we hadn't gotten to that yet.
Right.
Yeah.
Okay, so 14, Hunter.
First, you'll start by writing out 2x minus 3 times 2x minus 3.
Yep. And I'm going to stop right here and say that even on the homework last night, I had some people just square everything that's inside the parentheses. So don't do that. That's another one of those things. If that's a 5-point problem and you do that, I'll count off 10 points.
I'm counting off all points.
So keep going.
All right, and then we'll just start distributing the 2x to the 2x, which will become 4x squared. And then the 2x to the -3 is minus 6x. And the -3 to the 2x is again -6x. And then the -3 to the -3 is +9. Which gives us 4x squared minus 12x plus 9.
Thank you. Okay, so then these Acme manufacturing problems that talk about revenue and cost and profit, they look messy, but they're really not. They're just, it's just trying to show you an application for doing operations with different polynomials. So this one says the Acme manufacturing has determined that their new computer will have a revenue function of R of x equals 16x minus 0.12x squared and a cost function of 24 plus 8.2x. So if you think about this, the revenue is the amount of money that's coming in, that they're taking in on these computers. The cost of the computer, the cost that it takes to manufacture the computer is 24 plus 8.2x. So the profit would be whatever you're taking in, the revenue, minus whatever it takes to produce the computers, which is x. So, Elliot, can you tell me what R of x minus C of x is going to look like? Just using substitution, just substitute the function for R of x and the function for C of x.
Yeah, I'm not sure about this one.
Okay, so R of x is what? What is R of x?
Oh, 16x minus 0.12x to the power 2.
Yep. And then minus C of x, what is C of x?
24 plus 8.2x.
Yep. Okay, so now what do we have to do?
We have to multiply.
Okay, so that is something that a lot of people would want to do, but what does that sign tell us to do?
Oh, to multiply by 1.
By -1, right? Just that second polynomial, right? So the first polynomial, I'm just going to write 16x minus 0.12x squared. It doesn't change. But what about the second polynomial? What's it going to become?
It's going to become negative.
Okay, so how would you write that?
negative 24. And then 82 would become negative.
Yes. And then what?
And that's when you combine it together. So 16x would become, hold up, I don't have my calculator.
That's okay. And
Isn't that 7.8?
uh-huh. So it's going to be 7.8x, okay. And then what else?
And put the rest of the remaining numbers down.
Okay. And I always like to do it in descending order of power because that's really, that's what most mathematicians do. So that's going to be 0.12x squared plus 7.8x minus 24, p of x. All right. So I say p of x and then I write f of x. Okay. All right. So now what would, coming back to you, Michael, how would I determine what p of 60 is? What would I do with the 60?
Well, so you go P of 60 in parentheses, and then you go equals, and then take all the x's in this solution we just got and plug in 60
Yes.
into the variable. So that would be 12, or I'm sorry, 0.12. Well, you'd have to work it out, but you know, whatever the result is.
Right. So you're going to take that 60 and put it in everywhere you have an x. Right. Okay. So I'm
Minus 24. Yeah, I need a calculator for that.
me too. Okay, so if you multiply that out, I get 12. Someone check me on that?
That's what I got.
Okay, so, but is it really 12? And 12 what?
Dollars?
Okay.
Thousands of dollars? $12,000?
Go back and go back and read the problem. Revenue and costs are given in thousands of dollars. So that means that the profit would have to be in thousands of dollars, right? So you get 12, but you have to keep in mind, go back to the problem. And when you're talking about manufacturing, if you get a number like 12, probably that's not, you don't want to stop there because it's probably not going to be just 12. All right, so 12, but that represents $12,000. So how would you interpret this problem? What is this number actually? What is 12,000? Is it revenue? Is it cost? Profit? Which one?
That's the profit.
That is right. So there's a profit of, and you can say this however you want, just as long as you get it right. There's a profit of $12,000 when what?
60,000 phones are sold.
Yes, yes, when you sell 60,000 phones, right? X is the phones produced and sold in thousands. So I'd say 60,000 phones are produced and sold. If you said sold, that would be okay. So read the problem carefully, make sure you get your units right, and make sure you're interpreting it.
It sounds like a bad business right there. It's like 20 cents a phone or something they're making. They're not doing very good.
All right, so you've hopefully watched the video. And so we just have these 6 problems. And I'm going to put you in groups in just a second. But first of all, I want to just talk about this. So GCF, greatest common factor, what does that mean in terms of a polynomial? What do you look at first when you're determining GCF?
You look at the
Oh, okay.
16.
You look at the numbers first, okay?
You take,
Okay.
you take the
And what is
greatest
the
number that
number
can
that
go into
goes,
both.
what's the
sorry,
number goes into both 8 and 16?
8.
Right. So in this case, the GCF is going to be 8. And then when you look at the variables, what do you take? What's the GCF as far as the variables go?
It's the lowest, I believe.
Uh-huh. Okay, so that's big, that's the hint on that one. And then factoring by grouping, you're going to do exactly what we talk about when we say get by grouping. And in this case, we're just working with 4-term polynomials. But starting tomorrow, you'll be having to use this with 3-term polynomials, depending on how Matthew goes about teaching this. But this is, you still have to know how to do this regardless. So you're going to group, and then you're going to factor out GCF, and then you'll factor again. So let's just do this first one together, and then I'm going to put you all in groups and let you do the rest, and then we'll come back and talk about them. Okay, so here for the first 2 terms, AB and 5A, what do they both have in common? What's the GCF for the first 2 terms? What do they both have?
A 1.
A 1 and what else?
A 5.
Well, they don't
Oh,
both.
wait, let's scratch that. Sorry.
Yeah, we're looking at these 2.
Yeah, that one has an A and a
A,
1.
and what about this one?
That's going to be 3.
That's going to be a 3. Okay.
Right.
So I'm going to take this AB plus 5A, 3B plus 15. And this one, I'm going to pull an A out. That means I'm dividing both of these by A, right? Factor means divide. So what am I left with?
B plus 5.
B plus 5.
These B plus 5, my bad.
Okay, and then on this one, same thing. I'm going to pull out what they both have in common, which is the 3. And what am I left with when I divide out the 3?
B plus 5.
Also B plus 5. Okay, so now we're continuing factoring. We look at both of these, A times B plus 5 and then 3 times B plus 5. What do they both have in common?
B plus 5.
They both have B plus 5, right? So I can factor out B plus 5. And remember, factoring is just the same thing as division. So I'm dividing B plus 5. And what do I have left when I divide out the B plus 5?
B plus 3.
B plus 3. Yes. Okay. So I want y'all to work on the rest of these. for the next 10 minutes, and then we'll come back and talk about them. So I'm going to go ahead and put y'all in groups.
Can y'all see that?
Yes.
Okay. She assign you problems, or she just say do all of them?
I think she wanted us to do all of them.
Okay. You already did this first one, huh?
I haven't.
This one? I think we did this one.
I think we did 37.
Oh, not 17. I think I did 17. Are you understanding this?
Mm-hmm.
Okay. So what's the GCF here?
8.
And what about the Y?
Mm. Well, I mean, I just did this one, and I ended up with 8y squared, and then y plus 2.
Yeah, so you want to put out a Y squared,
Yeah.
and then you get Y here. You're dividing this by 8y squared to get Y to the first. Plus 2.
Yeah, she gave us a few hints before she sent us out.
Okay. She didn't do it all the way, but she like told you.
Yeah, she gave us
That's what it was.
us the GCF and then the exponent.
Okay. What about this one? What's your GCF?
The only one I could see it being is -2.
Yeah, so if it leads with the negative, typically you pull out the negative. So -2. What about the x's? Can we pull out any x's?
I think just the one.
Oh yeah, we can pull out 1.
Mm-hmm.
That's it. What about this next one?
I guess it's the 4 again.
Yeah,
The
it
negative
leads,
4.
yeah, it leads with a negative, so pull
Yeah.
out a negative. We need to pull out 4. Yeah. And then P, how many P's can you pull out?
I guess that you could pull out 2.
Careful. This has what, 3, 2? How many are here?
Oh yeah, there's the one.
Yeah, just the one.
Yeah.
Well, what about the Q's?
They're like just the one probably.
Yep, just the one. It's the lowest number that you see there. Yeah, I think you got to be careful. I don't know. I don't know if this is what you're doing. But like when we see 16 PQ.
Yeah.
A lot of people, they don't see an exponent on the P and they'll think it's like 2 because it's what's on the Q out here. So be careful that you don't do that, I guess is what I'm trying to say.
Mm-hmm.
It's a 1. Like if you don't see it, this 2 is for the Q, right? And this P has a 1.
Yeah.
Same thing with this. If it was a 2 on the P, it would look like this middle thing right here, right? P squared, Q squared.
Are we supposed to be able to show a lot of work for these?
For
Because-
the GCF, not like a whole lot. I mean, it's going to be this.
Yeah, I only have the
Yeah, I
So-
mean, I did like the prime factor tree in the notes and everything for like the constants, but like being honest, if you can do it without doing a factor tree, then go for it. Like the factor tree is just like more of like a tried and true sort of method that's always going to get you there. But these numbers aren't too bad to find factors of, right? But if we do some weird numbers, like 105 or something, throw at you, it might be a bit harder to find out what factors.
Yeah.
May not be quite so obvious. But like between like 8 and 16, it's 8, right?
Yeah.
Between like 2, 18, and 8, the smallest thing there is 2. Like that's the most you can pull out.
Yep. It's probably harder when you get to bigger numbers.
Yeah, exactly. So I was trying to set you up with some way to like do sort of everything, right? But if you can do like some little shortcuts and you can just kind of grab it, these are small enough. You ain't got to do all that work. Okay, what's that? 3. Do y'all know how to do these guys? Y'all already did this one, huh?
Yeah, she showed us how to do the one.
What about the box? Did y'all do the box?
No, we didn't do that. She just did. I think she just did groupings.
Do you know about the box?
I know
Oh, I
about the
know.
box, but I don't know how to do the box.
Yeah.
Okay, so doing the box is the same thing as doing factor by grouping. But we put it in the box in descending order. So this is my u squared. God, I gotta try to do there we go. Minus u. And I have a plus 6u. And I have what? Minus 6. So if you want to do it box method, what you do is you look across and you look like up and down to find the GCFs. So if I'm going between u squared and u, I can pull out between u squared and u to the first. What's the largest I can pull out?
1.
Yeah, 1u, right? Or u to the first. Here I have 6u and I have a minus 6 I can pull out.
6.
Yeah, 6. And if it's a positive 6, you usually put the plus sign. Now we're looking here between u squared and 6u. I should be able to pull out. It's going to be
Mhm.
one coefficient, but the u's I can pull out like a single u, right?
Mhm.
And then this, if it leads with a negative, you want to pull out a negative. Between 1 and 6, I can only pull out 1. Between u and no u's, I can't pull out any u's. So can you figure out what this factors into? Hopefully. It should be right there.
U plus 6 and U minus 1.
Yep, u minus 1 and u plus 6 right here. So that's how to do the box method. And then the good thing about the box is you can check it. U times u should give you u squared. U times the minus 1 gives you minus u. 6 times u gives you the 6u. 6 times minus 1 gives you minus 6. Oh, is that right? Oh, man. I don't know. She's my dog has like bad dreams sometimes or something. I don't know. She just freaks out when she's sleeping sometimes.
Mine is behind me licking the door right now. And I was looking at him and I'm wondering if you guys can hear him, but
Nah.
I hope you can't.
Thank God. They have everyone. Okay. Y'all think I can get this last one?
I'm working on it right now.
All right. So you can either do like factor by grouping or you can do the box. Oh, gee, I worked through most of this deal. I gotta let y'all do like a little bit of work on your own, right? I can't do everything. All right, I think I'm gonna jump to breakout room 2 for a minute and see, make sure they're okay.
Thank you.
All right, sure. Yes. Ooh. Ooh. Are y'all getting this?
Yeah, I think I've got everything but number 43.
Did you do
How's
factor?
everybody else doing?
Oh, I could do a box like that. Oh, it's so much faster. Out of the box. Out of the box. You know the box method?
Yeah, I remember that now. I had forgotten about it.
Would that be necessary like on a test or something, or can we just do it linear?
So it's either doing the factor by grouping like that, or it's doing the box. It's taking the place of the factor by grouping is what it's doing. So if you can do this factor by grouping, then go for it. But like I think the box adds a lot of structure to it, because a lot of times when people do factor by grouping, they'll like forget an addition sign between their terms or something. This keeps things a little more straight, I think. But yeah, you can do it either way. But if you do box, we got something like u squared minus u. So we just put this thing in the box in descending order. We look across for greatest common factors. We look up and down for greatest common factors. This is the first power. So we're looking across here. It's u squared and u. I can pull out a.
U.
Yeah. And this is a plus 6u and a minus 6. I can pull out a. It leads with positive. 6 and 6, I can pull out 6.
Okay.
And here I'm going between u squared, 1u squared, and 6. So between 1 and 6, I can't pull out nothing. But between 2 u's and 1 u, I can pull out single u. And the last thing, this leads with the negative, so you always want to pull out the negative that leads with it. Between 1 and 6, I can pull out like 1. Between u and no u's, I can't pull out any u's. And so there, your factors are right there. I don't know, hopefully you can read it. Yeah, u minus 1 and u plus 6 on the outside. But like the thing about this is that, or what I like about the box method is you can check. We have u times u is going to give me u squared. I have a minus 1 times u is going to give me my minus u, right? So u times 6 gives me 6u, and this one is minus 1, and 6 is going to give me minus 6. So we can check these sorts of things and make sure we're factoring out the greatest common factor, make sure we're doing it correctly. It's a little double check. But like I said, either way is valid. Like whatever way you feel more comfortable with, it's all good math. Until it's not.